guess the genre of the music of a song given for the model. It's not it's a little bit a complicated code, so I want you to follow exactly step by steps. In this video, I'm not going to write the code again. I might copy some code, going to copy them for you, and I'm going to share them later with you. Okay, so before we start, I want you to make sure that you open first Google Colab. We're not going to work on Anaconda anymore for this project, and for all our neural network programs, we're not going to work on and with Anaconda, but we're going to work with Google Colab. So please open Google Colab. I'm going to share this video, this link with you. For Google Colab, I'm going to create file in a new notebook. Okay, so I'm going first to copy this link and I paste it in the list of things that I'm going, or list of the links and code that I'm going to share with you later. So this is Google Colab link. All right, so after I go to Google Colab link, I'm going to create a new notebook, and I'm going to start a new notebook from scratch, from zero. I don't need this anymore, so I'm going to close it. And here I'm going to change the name of this file to music genre identifier. Definitely you can call this file anything you want, no problem with this. So now I have my music genre identifier file ready, and the second thing that you need to prepare before you start coding is you need to create a new folder on your Google Drive. So make sure that you have your Google Drive account on your laptops, and go to My Drive, go to Google Drive, and on Google Drive create a new folder, and you can name this folder anything you want. Here I call this folder a music genre as well. You can name it anything you want, and inside this file I am going to share this kaggle.json link file with you. I'm going to share it with you in the email, and this file or this folder that you just created, only upload this kaggle.json file to it. So now we should have our notebook file ready and empty, and also at the same time prepare your Google Drive with this file that I should be shared now with you, kaggle.json. So for now, definitely, as we always used to start our programs, we are going to import some libraries into our code. As I told you, I'm going to copy some of the code from a code that I already prepared to save some time, especially during this video. I don't want this video to be like 3 hours or 4 hours. Hopefully we will be less than an hour. So here, every time I wanted to comment on a code, I will write comment. So here I want you to comment on this code, to comment on this code, to comment on this code, and so on. So every time during the presentation, or during the coding, or during the video, you are going to see a comment. That means this code should be explained using a comment that I want you to write. So you can do it now while you are practicing and writing the code, or if you want, you can just write all the code, and then after you run everything and after you understand everything, you can comment as you go. Honestly, I recommend that you do the comment while you are watching the video, so you don't have to watch the video again. So import librosa. Librosa is usually used in machine learning, especially to be able to read music files and waves files. Similar to NumPy and pandas, we use them to read from CSV files, also from Excel files and CSV files for data. Also, we use librosa to be able to read the waves and music files. So we imported librosa. We are going to import pandas SPD as well, definitely NumPy, and matplot. Because we are going to draw some graphs. Import OS, import file, import image. I'm not sure we're going to use this one, but just to be on the safe side, we're going to keep it for now. Import CSV from sklearn.model selection, import chain test. So we are always using this code, and you know definitely why we are using this code. And sklearn.preprocessing, definitely we are, every time we are working on machine learning, we are importing these libraries. So I want you to explain these codes. Okay, you can at least explain here only pandas and numpy and matplot. You can drop these for now. Import CSV, explain this one as well. Regarding keras and tenserflow, we use them. These libraries are specifically for when we are working with artificial neural network, ANN. So we are importing this library to be able to use artificial neural network coding. Okay, regarding warnings here, we are just importing this warning just to, if we have faced any unnecessary warning, we just imported this warning, and we are going to ignore unnecessary warning. So these codes is to ignore unnecessary warning. So for now, we're going to import some more libraries later, but for now we imported the most important libraries that we are going to start with. In case, and we will use more libraries later, we are going to import them later, but for now we're going to start from here. So I'm going to run this code first. This is how we run the code from Google Colab. It might take some time at the beginning, and once you see that now خلاص, it's done. So 4 seconds completed. So we finished this in 4 seconds. All code is correct now. We can continue. By the way, Anaconda might be a little bit faster, especially that this code is done online, so it might be a little bit slow. Some codes might be slower than others. In this case, I will just have to pause, because some data will need like 5 to 10 minutes to be loaded. So in this case, I will just pause the video, wait for it, then we continue the video. I'm not going to spend I'm not going to keep this video only for loading data. Okay, so now I'm going to add a new line. You can add a new line from here. We used to call it add new cell in Anaconda. You can do it from here, or you can do it just from here. You can click here, and this will add a new cell where you can add your code that you want. I'm adding now pip install.h5py py_yyaml and tf.nightly. These two codes are used when we are working with to handle big amount of data and CSV files. All right, so these are used if we are going when we want to handle a big number of data in CSV files. I'm not going to copy and paste these codes because I'm expecting and I think that these codes are a little bit still acceptable to write. So write these codes now, and also don't forget to definitely include the command as well. So in this cell here, we are going to install the library, or we're going to install some files and programs that will be able to handle, that will let Google Colab to handle big amount of data with CSV files. I'm going to run this code. It might take some time for you to run. Just wait for it. It will load and will install some files. For now, I'm going to just wait for it. So I think now the file is loaded, and all the files are installed on my computer or my Google Colab. After you run this code, you might need to restart runtime. Just click on it and click on yes. Don't worry, nothing will be lost. After you do so, I'm going to add a new cell, and this is where I'm going to add my remaining code for this program. After we install these required files to run a big number of CSV files, data with CSV files, I will need to if we can say, to connect my Google Drive with Google Colab. Using this code, we can link the Google Drive, G Drive, with Google Colab. Usually before in Anaconda, we used to open this file here, this folder, and we used to upload all the required files here. But if we do so now here, whenever we close this program, whenever we close this page, all files will be lost and we will have to upload them again and again and again. The only way to save, or the only way to not repeat the upload every time, is to upload the files into Google Drive. So this is what we are going to do. We are going to work and we are going to manage all our work on this folder here that you have just created on your Google Drive. And after this, we're going to connect this G Drive to this Google Colab file. How can we do this? We can just do it by writing this code from Google Colab import drive.mount G Drive, and here we're going to use this code so much. This code is called the change directory. Change directory, that means I want you to open the main Google Drive. So I'm going to run this code. After you run it, you will receive this website and you will receive the authorization code. To enable this, you have to click on this link shared by Google Colab, open it using your username and passwords, click on allow, then it will give you a link or a code that you will need to copy and then paste it inside this this code here, and just click on enter, and if the code is correct, you will see this message saying mounted at G Drive. So it is mounted now, they are linked now. You can work from here, we can link any code we can write, we want to write from the Google Colab, we can just apply it directly on our G Drive folder. So let's see now from Google Colab, what exactly do we have in our folders. So as I told you, we're going to use this code some good time in this project. So I'm going to change directory from, because the first change directory was for G Drive, that means the main folder, which is here, my drive. I'm going to change directory from G Drive to my drive/music-genre. So I want this code now to go to gdrive.mydrive-music-genre. Now whenever you see this, that means we are moved, we opened the music genre folder. All right, in case I want to list ls, that means list what are the files that I have inside this folder. I just click on play and you'll be able to see I have only one file, total one, and the file is called gaggle.json. This is what I have there. Don't forget, I need you to write a comment here to explain what exactly is this code, and I also want you to write a comment here to explain what exactly is this code. So far you have to write all of these codes using your keyboard, and also don't forget to include the comment as well. Let's continue. I'm going to open new code now, and I'm going to copy this code here to paste it here. We have a problem here. We only have one file, and we don't have, in music genre, we only have one file. We don't have the dataset. So how are we going to download, or from where are we going to have the dataset? You know, the dataset is where we have all these songs. We're going to download the dataset of 1,000 songs 1,000 clip. I'm not going to say song. 1,000 clip, part of a song or part of a music, some music mainly. And these 1,000 clip, we are going to study them and we're going to check on them to know what is the type of the music that they have there. The dataset as it is, as clips, is already available on Kaggle. But instead of downloading it from Kaggle and uploading it to here, we are going to use coding to download and upload directly to here. And this is how we are going to do it. We're going to write os.environ Kaggle configuration directory equal, and here you put the file location that you already have. My file, and I recommend to use the same naming to not be confused. My file is gdrive/my drive/music-genre, and this is the Kaggle file that we need to install. This code here is mainly used to download the dataset into this directory. So you can also here write your comment, like this code is used to install or to download the required dataset in this folder here. I don't want you to write this code because there's so many letters and so many maybe complication and slash, and so I'm just going to copy this code and I'm going to paste it here. This file will be shared with you. So when you reach this part, you can open this Word file previously shared with you. I think you already have it now by email, and just write the comment, copy and paste, and write the comment at the top. I'm going to run this code now. After you run it, boom, error. All right, I think I didn't run the OS. Maybe I didn't run this one. So we have make sure that you run all the codes that you have, or maybe after you install, run this code again, because after we installed the H5PY, we didn't run the code, the importing library again. So I think this was the main issue. Let me run this code again. This is where you can see that downloading from Kaggle started. The download should not take that much time, so I'm going to wait here. Actually, it's a big file, so it might need it seems like, yeah, finish in 11 seconds. So, and when you go back here now to your folder, you will find that, let me try to open this again from here. Refresh. We should have the file now. It might take some time to appear because, yeah, now it's there. So it's almost 1 GB file, and you can see that this is a zip file. So we have so many files and so many folders inside this file. Definitely we'll need to run it, and I'm going to show you now how we can run it, how we can extract the files and the required files, because we don't need all the files that we have here. We're going to only select some wave file that we actually need for our coding, for our model. So we're going to extract only these files, and we're going to drop everything else. So for now, this is exactly what we have. We downloaded this dataset from Kaggle. We have the dataset now on our folder. Our folder now has the Kaggle file and also has the dataset that we'll need, that we'll use for training our model. In order to open this file, we will need to, a file that includes folders, I will need to double click on the file. And then we'll need to extract the file. You can download, then upload again, or you can do this through the web. I'm going to do it directly through the web. So here I have connected the apps, which are zip extracted. If you cannot see this, if you cannot see these applications, you can just download the file, extract it on your Mac or Windows, and then you can upload it again to our folder. For me, I'm going to do it directly from here. sorry, I'm going to do it from here, from this application. And once you do it from this application, you will see that the application will need some time to open the file. I will just wait for this one here. You can skip, like it will need like 2 minutes, so you can skip for the next, not 2 minutes, maybe 1 minute. So skip the next 1 minute. All right, so we just opened the file and we just extracted the file directly on Google Chrome. But definitely this is not enough. I will need then to extract all this information, all the required information, into this folder here, the music genre that I have here. So how can I do this? By default, we will have 2000 files. Definitely, I don't need the 2000 file. I only need 1000 file. So even when you are going, if you choose to download this folder on your computer, this file on the computer, and extract it, then upload it again, don't upload all the files that you have inside this folder, but instead I'm going to uncheck all, and I'm going to choose specifically which folders and which files I need. I don't need these CSV files because I am going to create my own CSV files. I want all folders that have wave files. So, and as you can see now, we're going to discuss and we're going to open this dataset to explain it. So I will include in my dataset, and when you upload also your files, don't upload everything, just upload what I'm selecting. So I want all the files that I have inside the blues folder. So blues folder is included. I will have 10 folders. The first one is blues. Every folder has 100 wave file. I want definitely also classic one. So now classic will be imported as well. I also want country files. Country are selected. I also want disco files. They are selected now. I also want hip hop. They are selected. And the jazz selected as well. And also metal. All of these are examples of music genre, music types. And also pop. All of them are WAV file. Now you notice that some of the other files, some folders include PNG files. I'm going to give you an idea about it. Now we have Riga, I'm not sure what is this song type or what is this music type, and we have rock. This is everything that we need. I think so. Yes, this is everything that we need. The rest of the folders are PNG, and actually in this model, in this dataset, or in this program, in this video that we are sharing, I don't need these files. So I'm not going to import them. I'm not going to waste time on importing these files, because actually importing this file will take some time, some good time. So I will, once I'm going to start extracting, I will stop recording the video, then I'm going to pause, then I'm going to record again, because these files will take up to 5 minutes to be uploaded again into my G drive, into my Google Drive. So what I'm going to do here, I selected all folders that has WAV file. if you download this into on the computer, don't import the image original. We don't need it, no need for it, don't waste time on it. And then I'm going to extract to a drive. Once you start extracting the drive, you notice that we'll have almost 1000 files to be exported, and definitely this will take some good time to be exported. For now, I'm going to stop recording, and I will continue the video after the extraction is completed. Okay, so now after we loaded or we extracted all the files that we need in our model, when you open your folder, you'll be able to see that now we have a folder called data. Inside this folder, you will have a jar originals. This is where we have 10 files or 10 folders. Each folder represents a music genre that we are going to study and we're going to work on in our models. I'm just going to try some of these waves files. These are just normal waves files. Each one of them is 30 seconds. So we are going to study these music genre. Before this, let me inform you that one of these, and because I tried this before, one of these files, I think this one here has an issue, so I just want to remove it. Let me show you. This is a jazz folder. Inside the jazz folder, you go to file number 54. When you double click on it, it will not run. It's not running, so we have to remove this file. But jazz 55 is running without any problem, and 53 is running without any problem. So all of these files doesn't have any problem except this file. So this file is not running right, so I'm going just to remove it. Remove a jazz 54 file from your dataset, and instead of also this link or this file might be a little bit long, so instead of having data, I'm going just to remove this. I will rename it a jar only, not dash original, to make the code a little bit and somehow shorter. And I'm going to move the jar folder from the data. I'm just going to put it exactly this, move to, and I'm going to put it exactly in the main folder where I have the music jar. So move to here. So now the jars are here in the main folder called music jar. This data folder doesn't have any role anymore, so I'm going to just also remove this folder from here. And now this is the data that I have. I have the jars. This is where I have 10 folders, and every folder has 100 files, and these files are examples of music genre that you are going to study. Let me select all just to show you the 100. I think yes, we have 100 items here, and we have the same thing in every file except for the jazz file where we have 99 only. All right, so I think now we can start working on our data. The next thing we are going to do is we need to move from change directories. So I will open a new code here, and I will go to new directory. Don't forget to always, at least for every cell, to include your comment. And this one I'm going to run this code here. So I will go to change directory, Google Drive, My Drive, music genre, and this is where I'm going to list all the data that I have. Don't forget that the JSON file now is not needed anymore. We don't need this file, and also the .zip file is not needed anymore because these two files were used just to have this important file, the jars folder. This is the folder where we have our main data set. So I will, for now, I'm going to try to run the show you an idea about the files that we have inside. So these are the files that I have now inside genre blues. So this is just an example of the files that I have. This is not important. This is not related anywhere to the training or the coding that we are using. This is just representing and showing you how we can see these files instead of going to jar and go to blues, so genres blues. Instead of going here and reading the files from here, I can just print them or print the names from here. Definitely I cannot run them directly from here. I have to write some code to run them, but I can do it instead of going to the Google Drive. I can see them from here actually. All right, so let's try now to understand the data that we have. The next thing I want to do is I will try to change directory and go exactly to the blues folder. Change directory, Google Drive, my drive, music genre, and blues. I want to go to the blues folder. I will run this code here and list all details of the files that I have here. Exactly the same thing, but here the files are, I think, sorted somehow. Okay. And I will try to open this file here to try to understand what features this file has. So I will go here and again I will import this file. I'm going to explain this code for you now. So import time song name f blues dot 050 dot wave. Here the song name can be anything you want. You can write song name or song one or trial song, anything you want. I will just keep that as this song name. This variable name I just added, and the F here represent all the path, all the file names. So when you see the F here, that means it's not only blues. The song name now is blues 00 and everything before it, like all the path that lead us to this file. So when you see the F, that means G drive / my drive / my music or music genre / jar / blues, and at the end we have the blues file. So when you see the F, that means all the directory that lead us into this file. So now I have a new variable called song name, and in this song name I have this file, which is the blues file, the first blues files in the dataset that I have. Don't forget to include here your comment and also your comment here as well, and here as well. So we just can run this code, nothing will happen. After we run this code, we are going to try to understand, to have an idea about the data that we are dealing with. So here I will just copy and paste this code. No need to write it. I am going to leave it. I'm going to send it to you in the email as well. You can just copy and paste it. No need to write it all. So whenever you see this code here, I'm going to run it first so we can understand better what exactly is this code. Once you run this code, you will be able to see a graphical representation using PLT. You will be able to see graphical representation of this wave file. Because now we are going, when working with this wave file, we are not going only to we cannot ask Kaggle to, or we cannot ask the model to hear the music, but the model at the end will be able to read the numbers and read the frequency and read all song parameters, because every .wave file has some wave and some music parameter, sound parameters. We are going to use these parameters in order to decide if this, well, what's the type of music of the wave file that we are using. So definitely here we don't have, whenever we are working with music files, once the machine learning hear the music, it has to analyze it. So it has to go, or it has to process it using some examples like this, where the machine is going to study the music, or study the frequency, or study the categories of these songs, and based on this, machine is going to decide what is the type of music. So this is how our model is going to read the 1,000 files that we have. We just started with one example to show you how it's going to do it, but definitely we are not going to write this code 1,000 times for every song. We're going to see how we are going to do this. But this is how the machine learning is going to treat and study and analyze every file of the 1,000 file that we have. Okay, we're going to represent the data again in another way. Definitely don't forget to write your comment here. Your comment can be, this is a graphical representation. Comment. This is a graphical representation. I don't know why I'm always writing B here. You can, in your comment, you can say that this is a graphical representation of the frequency of the blues.000 file. We are displaying it using PLT dot plot. Okay, so let's also use another way to represent, to graphically represent our wave file. I will add a code here, and don't forget the comment as well, and I will run it, and also we'll be able to see graphical representation, heat map, similar to heat map, to the .wave file. Definitely I'm not a music expert, so I cannot, none of us are a music expert, I think, so we cannot understand, basically we cannot see any graph here. I think it's clear that the music started louder here, and somehow it changed to something else here, but I cannot see anything here, honestly. But the most important thing is the categories of this wave file. So we have something called CMAP, we have something called Noverlap, we have something called NFFT. All of these are parameters that our model will need in order to decide what is the music type. So these elements here, or these numbers that we have here, how the frequency of certain instrument in the music, how fast it is, how slow it is, how does it start, how does it end, all of these parameters, our model is going to use it. And I think all of these parameters are somehow here in these models, and also here, how fast it is, when does it start, how does it end, and all of these parameters, frequency of the music, all of these will help our model to better understand the data that it is dealing with. Don't forget that till now we didn't start any artificial neural network. We are just preparing our data. We downloaded the data and we took a sample, which is only one song, and we are trying to understand what the model is going to do. Definitely, we are not going to write this code 1,000 times. We are going to run a program that will run every song separately. So let's continue. We're going to also import this very important code. We have a very important code here. I'm going to add a new code file. Code. I'm not sure if you noticed that we miss a very important file, which is the data file. We always worked with machine learning since the start of the year. Whenever we work with any data set, with any program, we always have a data file, a CSV file that we need. And even at the beginning, we imported CSV file. We imported PD and NumPy, but we never use any CSV file. So definitely there is something missed here. Where is the Excel file? Where is the CSV file? Even when I asked you to import these dataset, these songs, I asked you to drop these and to not include them, because we are going to create our dataset, our CSV file, our data file. We are going to create it, and we're going to show you how we're going to create it now. So from these songs and from these categories that we have, we are going to build the data needed for our training, our model. So this is how we are going to create it. I am going to also send you this code as well. I don't want you to do any mistake with the spaces and so on. So here, this is what we are going to do. And let's have an idea about the file, the data file that we are preparing. This data file will have 1, 2, 3, 4, 5, 6, 7. The header will include 7 titles and 20, because this is a Python program running from 1 till 21. That's been running from 1 till 20. So I have a 20 here, and I have 7, and I have 1. That's mean we have 28 titles. Yani we'll have an Excel file that will have 28 titles. So this is an Excel file that will have 1, 2, 3, 4, 5, 6, 7, 28 titles. And it will have 1000 record, because we will have 1000 WAV file. Let me explain it another way. This is what we have. File name, chroma, RMSE, spectral bandwidth. All of these are parameters for the WAV file. And here we have also MFCC1, we have MFCC2, MFCC3, MFCC4 till MFCC20, but instead of writing here space MFCC1, MFCC2, MFCC3 and so on, instead of writing them all next to each other, we run a loop that runs from 1 till 21, and every time it will add to the header MFCC 1, 2, 3, 4, 5 and so on. And at the end we just added the label, header plus equal label. So that means we added another title, which is the label. So now let's run the code. I'm going to remove the printing part of it. I'm going to run this code. So the header is created now. And now I'm going to print the header. So now we can see that I have the file name, chroma shift, SFT, whatever it is, RMSE, centroid, bandwidth, roll off, 0 crossing rate. All of these are parameters required for the song. MFCC1, MFCC2 till MFCC20, which are these ones here. And at the end, I have the label. Definitely you will need to write a comment here. This is very important. And the comment can be: the following code will create the header required for the data file. So this is the header. This is where I have the titles, and the data will be under all of these files. So now I have created this header file, or I mean the header at least. After I create the header, I am going to add a new code, and this is where I am going to, we are done with all of these, and this is where I am going to create a data file, and I will add the header to this data file. Now in my Google Drive folder, I don't have any data file, but after I run the code, the following code, I will create a data file with this header. All right, so I'm going to click on run. Before this, let me move back to the main folder. So here I'm going to move to the main folder. Change directory G drive my music genre without this one here, and run. So now I moved to the main folder. This is where I have the music jar. Okay, don't forget to include this one, because if you create your data file in the incorrect location, you will face, or you will have an error. So make sure that before you create the data file, that you are in the music jar file. I'm going to add now a new code, and this is where I am going to create this data file. I think no need to copy this code for you. You can just write it, and I'm going to run the code here. Once you run the code, don't forget to include the comment. Once you run the code, we will have now in music jar a new file. I just created this one. Okay, so it will just be created. When you open this CSV file, you will notice that this is an empty file. It only has the title or the header that we just created. All the headers are there, and all the titles are there, as you can see them here. All right. So I think you can write the comment here that this code will create the CSV file in the Google Drive folder with the header previously also created. Let's continue next. This is very important as well. Don't worry, I'm going to send you this file, this code, without the comment. So let's explain this code. As you know, and as we previously did here, we just took one sample file, which is blues music, blues waves, and we tried to study this file. In our data set, we have 1,000 files. We have here, in jar, we have 10 different music types, and in every music type we have 100 files. So definitely we are not going to do it manually. We will have to do it using a loop, using a program. So how can we do this? First, we created a variable, and this variable called jars. You can call it anything you want. And this jars variable has all the folders name that we have in this file here. So we have rock, country, blues, classical, disco, hip hop, jazz, all of these. All of these names now are listed as this, as you can see here, separated by space. So blues, classical, country, disco, hip hop, jazz, metal, pop, rag, and rock. So everything we are going to do will be applied first to blues, then it will be applied to classical, then it will be applied to country, and so on. So the program, to make it easier, this is what the program will do. The program will go first to the blues folder. It will open the blues folder. It will take the first file. It will copy all of its parameters. It will copy all of its wave parameter that include the file name, the chroma SFT, the MSE, centroid, bandwidth, roll-off, zero crossing, MFCC1, MFCC2, MFCC20, and the label. It will copy all of these information and it will paste them inside this dataset. This dataset is currently empty. After we run this code, the code will go to every folder. It will go to every file in this folder. It will open it. It will copy the all required parameters from every file, and it will paste it inside our data file under each one, under its title. So this is in short what this program will do. I'm not expecting that you write a comment for every code here. All what I want from you is one, a general comment that can in general tell me what exactly is happening with this code or what is the role of this code. But your comment should be clear. When I read it, I need to understand it, okay? Because this comment is very important and I want you to take your time to explain it. I will explain it again. The role of this code is to open every folder, to open every type. The program will open every folder that we have for every genre that we have, and then the program will open every song or every .wav file that we have inside this code, this folder. Then the program will copy the parameters, the song parameters that identify the music type of every file by itself. It will copy all required parameters, and then for every file, so it will copy parameters of this file, then it will paste it in the data file that we have here. Then it will go to the next song in the same folder, do the same thing, another song. When this file finish all of the songs that we have in blues, it will move to classical music, to the classical folder. Then in the classical folder, it will take all the files, file by file. It will study it, copy and paste, copy the parameters, paste them in the data file. Then it will go to the next song and so on for all of the files in every folder that we have here. Definitely this will take a lot of time. So it will take at least 5 minutes. For now, I'm going to stop recording this video. I will wait until all the loading finish. Then I'm going to continue the recording again. But before this, let me run the code and let us see how this process is happening. I'm going to run the code here, and you will see that we have the file name, we have the FSTP, whatever it's called, and now we are doing this for every song we have in the blues. It started with the blues because first we have blues, then it will move to classical, then it will move to country, and so on. And at the end, we will have the label. So this is a blues, these are blues, this will continue, and later on it will go with the classical. Okay, you can notice this from here as well. Okay, definitely there's no need to wait for it from your side. When you are working on your computers, you will have to wait. You cannot continue the code unless you make sure that the data finished, or the data loading has finished, or data copying and pasting has finished. So now you will see that the program moved from the blues files, because I have 100 blues files, and now it moved to the classical music, and so on. I will stop recording for now, and I will continue after the file finish. So after you run the previous code, after you run this code here, this code, as we discussed before, it will copy all parameters from every song for every folder that you have. It will copy its parameters. It will copy all its information required for song recognition or music recognition. It will copy it and it will paste it, as we discussed, in the data file that we created here. Let's try to open now this file. When you open the data file, you will see that all of the information that we had here, all of these information, they are now copy it into this data file. We have almost 1,000 records. They should be 1001 with the header, but because we removed this one jazz file, now the total number of numbers of data that we have is 999. With the header, they are 1000. So yes, this is the data that we have. Now all the data is ready. And by the way, this is exactly where we used to start from in the previous programs. This file should be given to us in the data set, but this time we try to make it in a different way. We try to create this file, to create these parameters instead of just using them. And you can see at the end we have the label. This is where every parameter, all of these parameters can tell us what is the data type or what is the song type, music type of every record that we have. Let's try now to load this data set or this data CSV file into our program just to see it from here. Definitely, again, this code will not affect the program, but it will help us to maybe better understand the data that we have. I'm going to change directories now to music genre again. So this code will change directory back to music genre. I will run it and you will see that now I have the data file, and the data file now has records. I will then open this data file. You can just open it like this. We can just write data.pd. There's no need for this one as well, and there is no need for this one as well. You can just write data. It will print everything, all the data that we have. Okay, so I want you also to write your comment here. As you can see that we have the file name, we have the chroma STFT, whatever they are, centroid, bandwidth, roll off, zero crossing, MFC1, and all of these data are here with the labels at the end. We will have, I think we have 999 records. They should be 1000, but because we removed this file, now they are 999 record. So let's continue. As you know, data sets and machine learning doesn't work with letters and words, so we're going to replace these letters with numbers. We can do this using this code here. I think because we are somehow now familiar with these codes, I'm not going to copy and paste it. I will let you write it from your side. So this code here will change the labels into numbers. This code here will change the labels into numbers. Let me run the code. And now all labels were changed into numbers. All right. Second code is I'm going to create a data label. Data1, and I'm going to remove the file name, and I'm going to remove also the label. I'm going to remove the file name, and this is the file name. I will remove it. I will only keep the data inside, because as we said, here we are working with artificial neural network, and we are going to give the data without labels. So I will run the code here again, and I will print the data. As you can notice now, I remove the file name and I remove the label, so I don't have file name, and also there is no label at the end. And from now on, we are going to work with data1 and not with the data as it is before. All right, let's continue. Don't forget your comment. This code will create a new data variable, and in this data variable we are saving the data without the file name and without the label. Next, we are going to use the standard scalar to transform the data into scaled data. This is exactly the same process that we used to have before. I'm going to use data scaler to scale the data to have exactly the same level. So I will run the code here, and you will notice that the code now, or the array now, has changed to some limited number of range of data. Instead of having big numbers like here, and big numbers like here, and small numbers like here, now all the numbers are somehow between maybe -2 and 2. Then our data is scaled. Don't forget the data will be scaled according to data 1. We are working now with data 1, not with data. We are working with data 1, standard scaler. Okay, X here just to print them. So we have this, we identified here the scaler. This is exactly the same thing. I try to be fast here, but because we just did this we are doing this since the beginning of the year. We have a scalar equals standard scalar, X equals scalar dot fit transform. This is where we can fit the data 1 into the standard scalar that we created, and X just to print them, to see them. If you did it without the X, without printing them, that's okay. Still working, but without printing. And when you write just X, this will print data that we have inside this scaled data. Now we have scaled data called X. After we have the scaled data, you know that we're going to do the training and testing. I will add the code again. And here we actually start our training process. To make it a little bit easier for everyone, I'm going to also give you this code here, even that you know it before, but just to make it easier for everyone. Don't forget that the X here are big X and capital X. And here you will have to write the comment. You already know the comment. We are training. We are splitting the data into training sets and testing sets. We have 80% training, 20% testing, 0.20, and this is where we have the data shape here. There is no need oil for this one, but this is for printing. So in here you will be able to see the trained data and testing data. Okay. There is no need for this code. Khalas. No need for it. Just write trained data and testing data. No need for printing. Just do the training, and that's it. More than enough. Let's continue here. This is the very important part of our program. This is where we prepared all the data. We did the standard scalar. We fit the data into the standard scalar. We split the data into training and testing. Now we need to create a model to train the data, to train these data. This is how we create a model for artificial neural network. So from keras import models, from keras import layers. Model 1 equal models.sequential, layers dense equal 256, activation function equal relu, activation equal relu, activation equal relu, and activation equal softmax. I will just give you an idea what exactly is this. First, we need to import the models, and we need to import the layers. Before working with artificial neural network, we need to import these libraries. So it's very important to mention here that these two codes are used to import models and import layers, because as you know, in neural network we have layers, and now we'll see that we have also models. You cannot use models.sequential unless you imported the models, and you cannot use layers unless you import the layers. So we import the models in order to use the sequential model, and we imported the layers in order to use the layers in our system. The first layer.dense equal 256 with activation function equal relu, with input shape taken from X-train. This one is the input layer. First, because it is the first layer that we wrote. Second, because it has the input shape. So we know that we have 256 cells that will input data. Here we have two hidden layers and we have one output layer. So this model is of 4 layers. The first one is the input layer. Here we have the hidden layers, and here we have the output layer. So, input layer, hidden layers, and output layer. If you notice that, the output layer has 10 output. Why 10? Because our data set is of 10 different genre of music. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's why when we give the data, our data set, our model will give us 10 different answers. It can be 0, it can be 1, it can be 2, it can be 3, it can be till 9. If it is 0, that means it is rock. If it is 1, that means it is reggae or whatever. Okay, so we have 10 output nodes because we have 10 possible solution, and this is the output layer. I want you to write your comment here. This is also a very important comment that I need you to include. We have comment and we have a comment here. This is, I think this is very clear, and this one should be also now very clear by now. In your comment here, I want you to mention how many input layers. Definitely we have 1. How many hidden layer we have, and how many output layers. I want you also to include what is the activation function, general idea about activation function. I want you also to mention why do we have 10 output layers here. 10 output nodes, not layers, 10 output nodes. Let's continue. We are almost done. We trained our data. Now the only thing that we need to do is, we prepared the model. The only thing that we need to do now is to do the actual training. And this is where we do the fitting. This is the fit that we used to do before even. So I will also give you this code in this file. So we'll have model.compile. Optimizer is Adam. And loss is sparse categorical cross-tropy. And matrix is accuracy. Model.fit, x train, y train, epochs equal 500, batch size equal 128. I will give you a little bit some information about these codes as well. The optimizer is Adam because one type of algorithm that used in artificial neural network is Adam. Loss is a sparse categorical cross-tropy. As we discussed previously in our presentation, that some ways of calculating the error or to calculate the loss is by using mean square MSE, binary cross-tropy, categorical cross-tropy, or sparse categorical cross-tropy. So these 4 methods or these 4 functions can be used, as we discussed before, to calculate the loss of the model. And in this example here, we used a sparse categorical cross-tropy. Matrix is accuracy. And epochs is 500 because this model is going to try every patch is going to try it for 500 times. Definitely this code also will take some time. Let's try to run it first. And we receive an error. I'm not sure if I run this one. First we need to run this one. And then we run this one. Yes. So you will notice that the code will run, and every time it will show you what is the accuracy and what is the loss. Every time it will show you what is the accuracy and what is the loss. And the program will finish once it reach it reached 500. Maybe in your computers it might need more time, because maybe I run this code before, so a little bit faster now. On your computers it might need more than this time. خلاص, it's done almost. And every time you will have the loss and you will have the accuracy example. We are almost done with our program. Don't forget that you need to also to comment the comments here as well. And the final code here is just to check the we have to evaluate this model. We can evaluate it using test loss and test accuracy to see what is the percentage of loss and accuracy to the model. I will run this code. Before this, don't forget to include your comment. And this is where we can check on the loss and accuracy. It seems that our model is a little bit running, I think it's acceptable. Accuracy is 74%, which is acceptable, I think. Loss is 1.076, which is very acceptable as well. Maybe you will have different accuracy on your computers when you try the code. Maybe you will have different accuracy or different loss. There is no issue with this as long as the accuracy percentage is above 70%. As long as it is above 70%, and I think most of you will have above 70%, that's mean your code is running smoothly and you don't have any issue. Please, after you finish from the code and after you watch the video and try it on your computers using Google Colab, what I want from you is you click on File, you click on Print, and then you save this code as a PDF file and you share this file with me on a forms that I'm going to share also in the email that I'm going to send you. Okay, while you are working on the code, and hopefully if you reach this part of the video, that means you didn't face any problem, but I will also mention this in the email. If you need any help or if you face any problem, you can contact me or you can send me emails. Thank you for watching and waiting for your submission.